Every year, billions of plastic bottles are used for just a few minutes. Most people see them as waste. But this bottle's journey is only beginning. At first glance, it looks simple. But every curve, every thread, and every gram of plastic has been carefully engineered. Although it weighs only a few grams, this bottle is strong enough to protect its contents through manufacturing, transportation, and everyday use. But the moment it's empty, many people believe its story has come to an end. In reality, this is where one of the world's most sophisticated recycling systems quietly takes over. Unlike organic waste, plastic doesn't simply disappear. Without recycling, this single bottle could remain in the environment for centuries. Fortunately, PET plastic was engineered to be recycled, allowing its material to be used again and again. But before it can become something new, every bottle must begin the same remarkable journey. Every recycling facility sees thousands of bottles every hour, yet every one follows the same carefully engineered process. And from this moment forward, we'll stay with just one bottle as it travels through every machine that gives it a second life. The bottle's second life begins the moment it enters a recycling collection system, where thousands of discarded bottles start the same journey every day. As more bottles arrive, hydraulic equipment compresses them into dense loads, making transportation far more efficient. Compressing lightweight bottles allows thousands of them to be transported using far less space, fuel, and energy. Once compressed, the bottles are ready to travel from collection points to specialized recycling facilities. Every journey begins with movement, and now our bottle is on its way to a facility built entirely to recover valuable plastic. From the outside, the recycling plant looks like an ordinary factory. Inside, hundreds of machines work together with remarkable precision. Every load entering the plant is carefully metered, ensuring a steady and continuous flow through the entire recycling process. Before sorting can begin, tightly packed bales must first be separated back into individual bottles. Once separated, every bottle begins moving individually through a carefully designed network of conveyors. Up ahead, the bottle reaches one of the most intelligent systems in the entire factory machines, capable of identifying plastic in just milliseconds. Before a bottle can be recycled, the factory must first answer one critical question. Exactly what kind of plastic is it? Unlike the human eye, these sensors don't simply see color. They identify materials by the unique way each plastic reflects invisible light. Every polymer has its own molecular structure, creating a distinctive optical fingerprint that the system recognizes instantly. In just milliseconds, the sorting computer compares that signature against thousands of known material patterns. Once identified, the bottle's exact position is tracked every millisecond as it races down the conveyor. Now comes the decision. Tiny air jets will determine exactly where this bottle goes next. At precisely the right instant, a burst of compressed air changes the bottle's path without ever touching it. This process repeats hundreds of times every second, separating different plastics with extraordinary accuracy. Our bottle has been identified as high-quality PET, one of the most valuable plastics for recycling. But identifying the plastic is only the beginning. Next, the system must remove everything that doesn't belong, including caps, labels, and hidden contaminants. Although our bottle has been identified correctly, it still carries several materials that cannot remain during recycling. Even the cap is made from a different plastic, chosen for flexibility and durability rather than transparency. The label may seem insignificant, but its plastic film and adhesive must also be removed before recycling can begin. Invisible adhesive residue can contaminate recycled plastic if it isn't completely removed. Dust, sand, food residue, and tiny fragments of other materials often travel with every bottle into the recycling plant. Before washing begins, automated vision systems perform one final inspection to detect anything unusual. Every bottle is inspected in only a fraction of a second, yet the system can detect surprisingly small imperfections. Our bottle passes inspection and moves forward, while unsuitable items are automatically diverted away. Ahead lies the first major cleaning system, where years of dirt and contamination will finally be removed. Here, powerful streams of water begin preparing the bottle for the next stage of its transformation. Before plastic can become a valuable raw material again, every trace of dirt, dust, and residue must be removed with remarkable precision. Instead of using fresh water continuously, modern recycling plants circulate and filter water through closed-loop systems. Powerful rotating drums gently tumble the bottles, allowing every surface to be reached by the cleaning system. As the bottle turns again and again, high-pressure spray nozzles attack contaminants from every possible angle. Water alone isn't always enough. Heat helps soften stubborn adhesives that tightly bond labels to the plastic. Once softened, the label begins separating from the bottle without damaging the plastic beneath it. Detached labels are immediately carried away, preventing them from mixing with the cleaned plastic. Next comes friction washing, where controlled mechanical contact removes the smallest remaining particles. By this stage, the bottle is almost completely free from contamination, but one final separation still remains. Although they look similar, different plastics behave very differently in water, and that simple fact becomes the key to another remarkable sorting process. Water does more than wash the bottle. It also becomes a remarkably accurate sorting tool, separating plastics by one simple property density. Although they may look similar, different plastics have different densities. PET is heavier than water, while most caps are light enough to float. Inside the separator, carefully controlled water currents keep lightweight contaminants moving away from the valuable PET. Powerful circulation pumps keep the separation process stable, ensuring consistent performance hour after hour. Slowly, our bottle reaches the bottom conveyor, where only clean, high-density PET continues the journey. Excess water must now be removed before the bottle enters the next stage of processing. High-speed air knives remove the remaining surface moisture using carefully shaped sheets of compressed air. Warm circulating air completes the drying process, preparing the plastic for mechanical size reduction. For the first time since leaving the factory, the bottle is completely clean, ready to be transformed into raw material once again. The bottle has been cleaned, sorted, and prepared. The next machine will do something irreversible. It will reduce the entire bottle into thousands of small plastic flakes. Although the bottle is perfectly clean, it's still far too large for the next stage. First, it must be reduced into thousands of uniform plastic flakes. Gravity guides the bottle into the cutting chamber, where powerful rotating blades are already spinning at high speed. The cutting system isn't designed to crush the plastic. Instead, it slices the bottle cleanly between moving and stationary blades. The tiny gap between these blades is carefully adjusted. Even a small error can reduce cutting efficiency and increase wear. As the rotor spins, every pass removes another section of the bottle, gradually transforming it into smaller and smaller pieces. The fragments continue circulating until they're small enough to pass through a precision sizing screen. This simple screen ensures every plastic flake leaving the machine has a consistent size for the next manufacturing stage. Thousands of clean PET flakes collect below the granulator, ready for one final quality inspection. Powerful extraction systems remove lightweight dust, ensuring that only clean plastic continues through the recycling process. Our bottle no longer exists as a bottle. It has become thousands of perfectly cleaned PET flakes, the raw material for an entirely new beginning. Although the bottle has disappeared, its plastic is about to enter one of the most important machines in modern manufacturing, the extruder. At first, the flakes remain completely solid. A giant rotating screw begins moving them forward through the steel barrel. The screw does much more than transport material. Its carefully engineered shape compresses the plastic as it moves forward. As pressure increases, the flakes begin rubbing against one another and against the steel barrel, generating additional heat through friction. External heating bands surrounding the barrel raise the temperature with extraordinary precision, preparing the plastic for melting. Gradually, the edges of every flake begin to soften until thousands of individual pieces merge into a single continuous flow. By this point, the original bottle is no longer recognizable. Only purified molten polymer continues through the machine. Before leaving the extruder, the molten plastic must pass through an extremely fine filtration system that removes the smallest remaining impurities. Clean, uniform pressure is essential. Any fluctuation could affect the quality of every product made from this recycled plastic. Now the recycled plastic is ready to leave the extruder and begin taking on an entirely new shape. As the molten plastic leaves the extruder, it is still far too hot and soft to be used. Its next transformation begins immediately. The strands enter a carefully controlled cooling bath, where heat is removed gradually to prevent internal stress from forming. Guide rollers keep every strand perfectly aligned, ensuring they remain straight throughout the cooling process. By the time they leave the cooling bath, the strands have solidified once again, but their journey isn't over. Before cutting, every remaining drop of water must be removed to protect the quality of the finished pellets. Ahead waits the pelletizer, a precision machine that cuts continuous strands into thousands of identical pellets every minute. Every rotation of the cutting blades produces perfectly measured pellets with extraordinary consistency. Millions of tiny pellets collect together, each one carrying the material from countless recycled bottles. Automated inspection systems verify pellet size, shape, and consistency before the material is approved for manufacturing. The transformation is complete. What began as a discarded bottle is now premium recycled raw material, ready to begin an entirely new life. For recycling to truly succeed, the material must become something useful once again. Our recycled pellets are about to begin an entirely new manufacturing process. Before molding begins, the pellets are carefully dried. Even tiny amounts of moisture can reduce the strength and clarity of the finished bottle. Once dried, the pellets enter another extruder, this time not for recycling, but to manufacture entirely new products. The screw melts and compresses the plastic once again, storing a precisely measured amount of molten polymer for each molding cycle. Two precision-machined mold halves lock together with enormous force, preparing to shape the molten plastic. Molten plastic fills every detail of the mold, forming what will become the foundation of a brand new bottle. Seconds later, the mold opens to reveal a PET preform, a small test tube-shaped piece that will soon become a full-size bottle. Although it hardly resembles a bottle, this preform already contains the finished neck, threads, and sealing surface. The next machine will use nothing more than heat and compressed air to transform this small preform into a full-size bottle. In the next stage, this tiny preform will stretch, expand, and become the clear plastic bottle we recognize every day, completing one extraordinary engineering journey. The recycled PET preform may look nothing like a bottle, but it already contains one finished feature, the neck. From this point forward, only the body will change. Before the plastic can be stretched, it must be heated to exactly the right temperature, hot enough to deform, but not so hot that it loses strength. Heat softens the body of the preform while the neck remains cool, preserving the precise threads needed for the bottle cap. Timing is critical. The preform must reach the mold while it is still at the perfect forming temperature. Precision-machined mold halves surround the preform, defining the exact shape of the future bottle. A stretch rod enters first, pulling the softened plastic downward before compressed air begins expanding it outward. In a fraction of a second, high-pressure air forces the softened plastic against every contour of the mold. Cooling channels inside the mold immediately remove heat, allowing the new bottle to solidify while holding its precise shape. Only seconds after entering the machine, the recycled plastic has become a crystal-clear bottle once again. The bottle has completed its physical transformation, but before it can hold a single drop of liquid, it must prove that every dimension, every surface, and every wall thickness meets exact engineering standards. Every newly molded bottle must pass a series of inspections before it's trusted to carry food or beverages. Laser scanners measure the bottle's dimensions with incredible precision, ensuring every millimeter matches the original design. Cameras inspect every surface for tiny defects that would be almost impossible to see with the human eye. Even the thickness of the bottle walls is checked, ensuring the container is both lightweight and strong enough for its intended use. A pressure test confirms the bottle can safely withstand filling, transportation, and everyday handling. Approved bottles continue forward automatically, while any bottle that fails inspection is removed from the production line within milliseconds. The empty bottle now arrives at one of the fastest machines in the entire factory, the beverage filler. Each bottle pauses beneath a filling valve for only a moment, yet receives an accurately measured volume every single time. Immediately afterward, an automated capping system seals the bottle, protecting its contents from the outside world. What was once discarded as waste has completed an extraordinary journey. But one final step remains before it reaches consumers around the world. The bottle is now structurally complete, but it still has no identity. That changes in the next few seconds. Large rolls of printed labels unwind with remarkable precision, feeding the machine at exactly the same speed as every passing bottle. A rotating vacuum drum captures each label and positions it with millimeter-level accuracy before application. In a perfectly synchronized motion, the label wraps smoothly around the bottle without wrinkles or air bubbles. With its label in place, the bottle now carries everything from branding to nutritional information and recycling instructions. Individual bottles quickly become organized groups as automated equipment prepares them for shipping. A continuous sleeve of plastic film surrounds each group before heat shrinks it into a secure package. Robotic pelletizers lift entire packs at once, stacking them into stable loads ready for transportation. Layer by layer, the pallet grows into a carefully balanced load, capable of traveling hundreds or even thousands of kilometers. Less than a day ago, this material was a discarded plastic bottle. Now it begins another journey, this time toward homes, stores, and people around the world. The story doesn't end when the bottle reaches a store shelf. In many ways, this is where its next journey truly begins. From the outside, it looks just like any other bottle, but inside its walls is the result of dozens of precisely engineered manufacturing steps. Every recycled bottle reduces the demand for newly produced plastic, allowing existing material to remain in use for longer. Recycling is more than collecting waste. It is an industrial system where chemistry, mechanics, automation, and precision manufacturing work together. Each machine performs one specialized task. Alone, none can complete the process. Together, they transform waste into valuable raw material. Even after reaching the consumer, the engineering continues. The bottle has been designed so it can be collected, sorted, and recycled again. If properly collected, the same material may return to a recycling plant again and again, forming a continuous manufacturing loop. Millions of bottles follow this journey every day, each one representing a remarkable combination of science, engineering, and manufacturing. The next time you see a simple plastic bottle, you'll know there's an extraordinary engineering story hidden inside it. From a discarded bottle to a new beginning, every stage of this journey demonstrates the power of engineering to transform yesterday's waste into tomorrow's resource. And with every successful cycle, the journey is ready to begin once again.